All right, we are picking up right where we left off with our APES energy keynote. We just finished talking about the difference between renewable and non-renewable sources of energy. So where can we start with this problem that we're using too many non-renewable sources? Well, in the immediate future, there are some alternatives to using non-renewable sources in sort of a better way, or different sources of them that may help us meet our energy needs. Those are clean coal, methane hydrates, oil shale, and tar sands. So I'm going to go through each one of those. Clean coal means that we're trying to clean up the emissions that are related to burning coal. We know that burning coal produces a lot of sulfur, carbon dioxides, and other greenhouse gases that contribute to global warming, as well as contribute to air pollution, smog, and human health. So coal actually could meet the world energy needs for many years. There is a lot of it, but how can we reduce these negative impacts? We talked a little bit about this in class. I'm just going to brief over it. We can wash the coal beforehand and remove the minerals and impurities. We can use scrubbers that capture the sulfur dioxides and the carbon dioxides from the flue gases, so they clean it on its way out. And you might see the word flue used when we're talking about burning coal. So what is a flue is my question to you, and I'd like you to figure that out and jot that down in your notes so that you have that reference point next time you come into contact with it. Next is there is an interesting amount of methane hydrates available for us to use as energy. And what methane hydrates really are is just natural gas. So whenever I use the term natural gas, or whenever I use the term methane hydrates, or sometimes just methane, they all are referring to the same thing, CH4, that can be converted into hydrocarbons for energy. So what we have found is that there are many methane hydrates. Methane can be locked in frozen ice. So when we talk about the ice caps melting and glaciers melting, this is a bad thing because more methane is being released into the air as the ice melts. But if we can capture it, it can be a source of energy for us. And specifically also on the ocean floor where it's very cold and there's high pressure, there's a lot of trapped methane that we could capture and use as energy. It could supply our energy for hundreds of thousands of years. The biggest problem, however, is that burning the methane and natural gas obviously still produces carbon dioxide and contributes to global warming. It's not really an overall solution. Temporary, maybe. We could get oil from oil shale, which is basically finely graded rock that's made up of a chemical that can be converted to oil. We call that oil shale. But the problem is there's a lot of mining associated with it. We are blasting, drilling, crushing, heating, and we have to clear away a lot of the environment, and we are destroying a lot of the ecosystems as a result. Also, we're still using oil, so it still is pollution and contributes to global warming, and because of the nitrates and sulfates that turn into acids in our atmosphere, it contributes to acid rain as well. A third option is tar sands. This is what Venezuela has a lot of. They are basically oil that doesn't flow very well. You need really specialized refineries to convert it, and there's a lot in Venezuela and Canada. And it used to be too expensive to use, but now with the price of oils, it's becoming an economical solution as well. It just requires a lot of processing. Just really quickly, if you ever see the acronym OPEC, OPEC, it stands for Organization of Petroleum Exporting Countries. Venezuela is one of those. Saudi Arabia is another big one. Basically, based on the amount of petroleum they are selling, these countries control our oil prices. We are in what is called an energy crisis. Because we are using non-renewable sources, we are going to run out. Our oil reserves are predicted to last only 50 more years. Now this of course doesn't include other sources of energy, but oil reserves, only 50 more years. But industrialized countries, when China and India continue to become developed, they're going to use even more and more of the oil reserves, and this predicted number could decrease. And obviously the prices of oil will increase as we continue to decrease in the amount available. So let's just talk about these three different sources of non-renewable energy that we use. We have coal, oil, and natural gas. talk about where they're from and basically how it works really quickly. Coal we get from surface mining or underground mining. We can mine for it. And then what we need to do is we need to get the right size, we need to crush it, we need to wash it, and then we can burn it for energy. And we can also actually convert solid coal into liquid through some new technology. Oil is found trapped in the earth, and it's trapped in very specific places. Geologists that can find oil get paid a lot of money, and what they're looking for is sandstone with a layer of limestone below it. So we're looking for something like sandstone that will trap the oil, and something that doesn't have any holes in it, is non-porous like limestone, that will keep the oil from moving from that location. There's usually natural gas present with it. So when we drill a well, we puncture the limestone, and the oil's under so much pressure it just flows up naturally, but we're also releasing some natural gas as well, which we could use as energy as well. Then we need to process it at a refinery. The way we process oil, because oil is really a mixture of a lot of different things, the way we have to process it is called cracking. We warm it to different temperatures, and we boil off the different types of oil depending on the temperature that they boil at. So we can separate the oil into gasoline, heating oil, diesel oil, asphalt, etc. So as in this picture shows, it's trying to show, the crude oil, which is what we get out of the ground, goes into the pipe, and we have different sort of levels at temperature that we boil the oil at, and depending on the temperature it's being boiled at, the oil that boils at that temperature will be able to come out. So here you're separating gasoline, kerosene, diesel oil, and lubricating oil. So that's we just know that they separate the different types of oil, or you just know that oil refinery means separating the types of oil based on temperature and boiling point. As far as reserves, we probably have 300 more years for coal, maybe 50 more years for oil. Natural gas is uncertain. We have a lot of it trapped in different areas, mainly in Russia. We have 40% of natural gas trapped in Russia, and a bunch more in the Middle East. The Middle East is the source of all of these, but coal is probably largest in China. Coal is very abundant all over the world, and it's pretty stable because it's a solid, and you get a lot of energy out of it. In the USA, it's cheap because the US government actually pays money in subsidies to keep the prices low. But the cons are that we're going to degrade the environment when we're mining. We're going to cause erosion, runoff, decrease in biodiversity. And so I want you to just think of what type of things might run off from these areas. So jot that down in your notes. Think of what types of things might run off and become a problem here. The burning also releases mercury, sulfur, and radioactive particles into the air. So these are all issues related to human health. And then obviously we're still contributing to global warming with the release of carbon dioxide. Oil is similar. It isn't expensive for now. It's easily transported and you get a lot of energy. And it's really versatile. We use it in plastics as well. But the reserves are limited, and it produces a lot of air pollution, sulfur oxides, nitrogen oxides, carbon dioxides. And the drilling disturbs the ecosystems, and we could have oil spills that kill the ecosystem, so a lot of drawbacks there as well. Natural gas, pretty much the same as oil as far as pros. The cons would be that the methane contributes to global warming even more than carbon dioxide. All right, so an option to replace maybe our dependence on fossil fuels would be nuclear energy. So we're going to talk about that for a bit, the pros and cons of that. There's two types of nuclear energy. You can make atoms split apart and release energy. We call that fission. Okay? Or you can put atomic nuclei together. You can merge atoms, and we call that fusion. But really, nuclear fusion, even though it produces a lot of energy, it has not been very economical yet. It costs a lot of money to do this right now. So we really only use nuclear fission, so a splitting of atoms. And the types of atoms that are split are only two. We either use uranium or plutonium. Now these are both elements from the periodic table. They're simply used in this process and split into smaller nuclei, and that releases just a ton of energy. So we get a lot of energy from nuclear fusion. Oopsies. This is supposed to say fission. So you can correct that in your notes, nuclear fission. This is an exothermic reaction, meaning it therm or heat leaves, exits, and we release that. That heat is used to produce steam that turns generators to make electricity. I want you to briefly look up the word generator and tell me what is a generator and also what is a turbine. Both these things are good terms to know when you're talking about making electricity. Jot that down in your notes. But the problem is we are worried about nuclear explosions and we must control that reaction. So the energy is just a ton more than oil. If there's no pollution from, no air pollution from nuclear fission, and we get really reduced amounts of carbon dioxide emitted, there's just low pollution all around, and we don't really disturb much of the land. But the problem is the nuclear wastes after this process are highly reactive for thousands of years. We can't dispose of them. They keep collecting, and we must somehow control them, package them away from everywhere else. But what about terrorists, or what about accidents that may happen? If anyone would get a hold of these nuclear wastes, it could be really dangerous for people all over the world. So where do we store these? How do we avoid nuclear explosions? And it really is just a huge amount of money to clean up anything that happens. So it's up for debate, but they are very, very useful in terms of energy. So what does the nuclear reactors look like? Basically at their core they have fuel rods stacked up. The uranium is the fuel, and we have systems in place to make sure that the reaction doesn't get too hot, too fast, or too violent, or we might get a nuclear sort of explosion. So we have control rods that move in and out and absorb extra neutrons to slow down the reaction. We have a moderator that reduces the speed of the neutrons. All these are just to slow down the reaction so it doesn't get too out of control or too fast. And finally we have coolant, usually water, that removes heat, and that's going to produce the steam to generate electricity, which is the whole point of nuclear energy. So this is sort of showing that. We have the reactor over here. We have the uranium being split, and we have some of that turning a turbine, and we're also cooling it in the cooling tower so it doesn't get too overzealous, too extreme, and the turbine generates electricity, and that is sent out to the community. All right, now let's talk about some more really renewable sources of energy that could be in our future. One could be hydroelectric power. Hydro meaning water, producing electricity. Basically, it's a dam. You put a dam in the middle of a river and you stop the water. And then you slowly let the water be released through the channels that you made, and you put a turbine in the way so that as the water flows, it turns your turbine and thereby generating electricity. Now the pros is it's really low cost. You set this up and it doesn't need a lot of maintenance. There's no pollution, and the dams can control flooding in some ways, and it can be a really great source of energy. However, the dams do destroy wildlife, and they stop fish from migrating. And where you put the dam, you create a huge flood area behind it, and people can't live there anymore. And just the slow-moving water is just a breeding ground for insects. Insects love standing water to reproduce in, especially mosquitoes, and that can lead to the spread of disease. And also, if you think about all the farmland that's downriver from a dam, it's going to be deprived of the nutrients that were in that river, and that could harm the ecosystems or the agriculture down the river. Basically, this is how it works, though. This was the normally flowing river from left to right. The river was flowing past, and then we put up this dam right here. We stop the water, okay? Now this intake can be opened or closed, and when we open it, water flows through, goes past the turbine, turns it, generates electricity that goes out to the town, and the water can keep flowing down the river. So again, fish though can't really swim back up this river, or can't really swim back up through this dam. They'd be injured by the turbine, and there's not a lot of space, and so it's not really very good for the wildlife of the natural river. Salmon are an example of this. Salmon are migratory fish that do this. They hatch in rivers and streams, and then they swim to the ocean to live, but they come back to the river to reproduce later. But for example, in the west of the US, dams block every major river, and salmon can't do this. So we're seeing a huge decrease in salmon population as a result. So this completes part 2 of the presentation. On to part 3 in just a bit.